Once again, for all of you, a very warm welcome to SupportVectors weekly paper reading. The topic today pertains to the theory of the mind, an interesting concept as it pertains to AI agents. Today, we have a distinguished engineer and technical leader from Cisco, uh, Krishnan Ramaswamy, and he has kindly agreed to present and explain this interesting paper. Krishnan?
Yeah, thank you, Asif. Welcome all. Yeah, this paper is indeed very interesting, and it's very useful to all of us who are now into, some of us or all of us are into implementing the agentic framework and automation in our companies. So this paper came out on January 26th this year, and it mainly talks about a lot of interesting ideas in terms of providing empathetic responses. How do we enable our agentic framework and agentic automation and agents to provide provide a response that has a lot of empathy and sympathy in that responses. What I'm going to do this paper is about 30 pages. There are a lot of theory and a few mathematical calculations. In order to help us to read the paper in a sequential or easy way, I do have a slide. This slide deck is mostly 90% of the content is from the paper, but it helps us to focus on in a few areas. And let me start with those slides, and then I will as well go to the paper for adding more details to that. With that, let me start with the slide. And then I'll go to the paper when now the slide needs more details. So these are the topics we want to cover today. We will cover the abstract of the paper, and I'll give you some introduction. This introduction helps setting the context to all of us, and then we go into the paper, directly into the paper content. All right. So here is the main gist of the paper, right? When we implement agentic conversation using any agentic framework in the LLM world, either between the agents or between agents and human, how do we know, the empathy is taken care? A lot of us who are into this today, we probably use LLM to understand or what to respond back to the other side, the agents or humans conversing with this agent. And then during the time, we probably not focusing on the empathy factor today. This is an evolving field. And then if you look at this conversation, imagine there are two agents talking to each other. One is a sympathy needing agent, and the other one is an empathetic agent. So you may want to visualize, right? When we talk about the agent here, you may want to visualize, there is a personal agent behind some persona, some real human being. And there are agents either talking to the persona, the human being, or it is talking to the personal agent of the human. So there are multiple combination of such scenarios possible. But for the purpose of the paper, imagine there are two agents, sympathy needing agent and empathetic agent, right? And this is a paper, is basically the idea here is when you look at this conversation, there are some aspect of empathy is being responded by the empathetic agent, but the paper is trying to explain this is not sufficient. And there are many other things we need to take care in order to improve the way the empathetic agent responds back to the agent who needs a sympathy in the conversation. This looks simple, but when you really think about human conversation, and the era of agents and robots are now trying to communicate to the other side, the sympathy and empathy and understanding others' feeling is very, very crucial in making it a very successful, useful agent. So that sets to the abstract, leads to the abstract. So in this paper, in the study, we propose a novel paradigm called TOM agent, that is theory of mind agent, designed to empower LLM-based generative agents to simulate theory of mind. And I'm going to talk about a little bit about theory of mind and then what is BDI, to do that theory of mind. But the paper starts with a claim that they have proposing a new methodology, to come up with the theory of mind agent, right? That's the purpose of this paper. And then part of that is understanding the mental states. Mental states here refers to the agent's mental state. that agent could be a personal agent to the real human being, and understand the what we call BDI. What are the beliefs and desires and intention of the the agents communicating in the setup. What is a key concept in this paper? In this paper, as we go, one of the concepts here is how do we enable these agents, which is collaboratively working together, right, to understand other sides, I won't say motivation, other sides beliefs, other sides desires, and then based on understanding of the other side, it can formulate how to respond. And that's the main goal of this paper. How do we bring in the concepts, methodology, and process to understand the other side agents need, and understand the behaviors and understand the desires, and then formulate the response. And you can imagine, if you're aware of theory of mind, there are many aspects to that. There are first order thinking and second order TOM. We will touch upon what it is. See, as I go through the paper, this paper, even though it looks simple, it inspires all of us to think more and more, right? And this is more of a study of, starting from human understanding.
Oh, sorry.
Yeah.
You're doing an airplay to that.
Okay, there is some noise. All right. So that we'll go into that. So let's start with a simple visual understanding.
Sorry, I apologize.
Yeah.
It's only impact here.
There is some background noise.
Yeah, like he accidentally tried to do airplay to this one.
Hello.
Oh.
Ask if there is some background noise. You may want to put in. Okay, thank you. So we start with the theory of mind. What is theory of mind? Theory of mind refers to the cognitive ability to understand others, that others have their own beliefs, and then they have their own desires and emotions and intentions, right? That might be different from all of us. This is, again, if you think from, today's agentic point of view, this applies to the human psychology. Same thing now we want to apply to the agents. Now, agents need to understand, others' beliefs, others' desires, others' emotions. If the agents can understand that, the agents, which is a agent in our case, can respond in a way that other side can, feel sympathized and with high empathy from us. So that's the whole idea. In the picture, try to illustrate what is theory of mind in a normal setup. And what are the key concepts of theory of mind? You can say it's understanding of the mental states, right? And it's understanding that someone has a belief that's different from reality. That's also a key thing. And then perspective thinking, seeing things from other person's viewpoint. Though, see, these are all the concepts from psychology point of view. You would see that same thing might apply to the agents that we are implementing. And then social communication deception, right? These are some of the concept of theory of mind. You're welcome to read more about this theory of mind. A lot of information in the web, Wikipedia. But in our paper, we need to think about this, how this can be applied to our agentic implementation, agentic behavior, agentic response implementation. All right, how can one strengthen empathy? This is not in the paper, but this is, I wanted to give an introduction to in the human era, in the human space, right? This is how you can, these are some of the concepts behind how do we strengthen our empathy. Just take a look. Now, after you take a look, for example, active listening, or ask for a feedback, right? And ask questions and recognize feelings. So you would see that, these are the things, eventually we need the AI agents and robots and humanoids to possess this empathy, right? It's benefit all of us. So this is this paper you can consider as one of the paper to inspire us to think, the empathy is one of the key element of our agentic response. And as we know more about these empathy, and as we need more to put it in our agentic framework, and then it helps to strengthen our agentic collaboration. The other thing I thought, today's agentic implementation, if you look at the way the multi-agents are communicating and collaborating each other, if it has some sort of empathy and some of this understanding, it could be possible. These are just thought from my mind. as we incorporate some of the empathy in all our agents, it's quite possible that agents will work together more in a fruitful way, and then solve some problems in a way that it's complicated to solve. So that's my thinking at this point. And let's proceed about this paper, and we'll talk about the next steps towards the end. All right, so from the theory of mind, now let's go into theory of mind in AI agents. So in the AI agents, incorporating the theory of mind, meaning, basically somehow, bring in the capability to understand the, other side, which is either an agent or human, right? Understand the mental states of the other side. And that is a definition of theory of mind in AI agents. And why do we do that? And thereby enhancing their capacity to collaborate, negotiate, and communicate in a manner very similar to human cognition, right? So essentially, the bringing the theory of mind into the AI agents will improve the enhanced collaboration, will improve the negotiation between the agents, and then it will probably improve the communication between the agents. Sometimes, you can imagine the agents we develop is going to be interacting with the other agents, like Asif was mentioning MCP protocol. You can imagine in the future, we'll be talking to the agents which we are not designed, right? In that sense, you need to negotiate, the agent need to negotiate and then communicate and then get things done. And then obviously the customer service is an essential part of infusing this theory of mind concept into that agents. So these are some of the things we bring into the agents. How do we create the agents with theory of mind? This goes into a little bit implementation, but just today there are rule-based approaches, there are machine learning-based approaches, there are hybrid approaches. See, in this paper, as the paper explains, it will talk about the combination of rule-based and machine learning is kind of the hybrid approach is followed in this paper. Right. What are the challenges in creating agents with theory of mind? One of the challenges, this paper actually solving is about tracking the mental states. Right now I'm putting this as a mental, challenges, but this paper ideas presented in the paper helps us to, resolve those challenges. One is defining the mental state, and then understanding the other's mental state, and based on that, forming the response from us. As part of that is, the complexity of the reasoning is also involved in this. So you can imagine until now, when we implement until now, before this paper, it is possible that folks might have figured out how to incorporate this empathetic response back to the, in the agents. But this one of the paper formalized that. So in that sense, if we understand this paper, like a formal approach, we can extend from this and then, go beyond this paper that implements. Okay, now we are stepping into the next little bit concept, then I will directly go into the paper, right? My idea is to introduce some few concepts in the presentation and then go into the paper. And behind this theory of agents, the way you can think about is to design in order to bring in the theory of mind into that agentic framework. We want to understand, we want to define few things, which is belief, desire, and intentions, which will, try to communicate, for this agent, these are the desires I possess, these are the intentions, and these are the beliefs I have. So first thing in this paper, or in this, incorporating that, what I call TOM, we need to think about, each agent's BDI. It could be, every agent we define might have, multiple beliefs and multiple desires and multiple intentions. So here the beliefs are something, the knowledge that agent possess, right? Like the way we believe in something. And then desire means some goal, this agent want to achieve some goal, you can consider as a desire. And then intentions here it refers to the actions or path it takes to achieve this goal. So that's how the BDA is defined. And you can see, you can read, what is belief and desire and intention. Intention represents the actions that the agent plans to take to achieve its goals, right? And in this belief, desire, intention, there is a idea you have to keep in mind in this paper. As the paper proceeds, they talk about how to design this responses using first order thinking, and then for the second order thinking. So what is first order thinking? Alice thinks that, for example, Alice thinks that Bob likes the football. It's basically you can say the first order means very immediate thinking, what others think. The second order means, example is Bob thinks that Alice believes that Bob likes football. It's a second order thinking. So you might ask why the agents need to wonder about second order thinking. By knowing the second order thinking, it can predict or it can figure out the right way to respond. We will talk about that in this paper. Okay. And how does this work? This is what this paper is going to talk about. This is again, it's the same information we talked about. This is the content from the paper. You can essentially go through this, but this is the same idea that we talked in the previous slides. The last bullet, intentions help stabilize the agent's decision making by focusing on specific course of action and excluding choices that are inconsistent with the current intention. So that is one of the aspect of the intentions. It helps the framework to decide the right path in the course. All right, so let's go to the problem statement. Now that I gave you some introduction about some of the theory of mind and BDI, I'm going to take you to the paper, and then from here we are going to walk through the paper. So we talked from abstract, we talked about that, right? I just highlighted the color so that these are the key points from the paper, and then we talked about the introduction. And then the first example, the way the paper goes, first they want to give an example, and then they want to get into the actual methodology. The example they are going to talk, let me go back to the slide, and then I'll come to that. Again, I'm going to the paper. I'm just going through the sequence of the paper. So in the paper, they mentioned about two agents, Bob and Alice, right? In the left-hand side, Bob, and then right-hand side, Alice. Now, imagine that we are talking about how to implement the theory of agents in this agentic platform, right? So what we do when Bob is a person who gets initialized. Here we are talking agent. When the agent gets instantiated or comes alive, the agent already has set of beliefs, set of desires, and set of intention. So you can imagine, it basically comes from some data file and gets initialized, right? And through the LLM, this Bob agent able to synthesize that, and then and form a idea about what is the belief, desire, intention for the Bob. So that is the first step happens in the methodology in the paper proposed. Similarly, in the right-hand side, Alice also goes through the same process. Alice, initialized with her own belief, desire, and intention. That's in the blue color, right? But the key concept in this paper is, as the time goes, these systems, for example, Alice will come to know about, what is the BDI. BDI means, belief, desire, intention of the Bob. That's a mechanism in which Alice will come to know, and then Alice will maintain the other agent's beliefs, desires, and intentions, and then make some crucial decisions, right? By knowing the other side, Bob's side, how the Bob thinks, how the Bob believes, and Alice would be able to generate responses in a better way with more empathy. So now, if you think about the human psychology, right, when we deal with, in our corporate setup or in our personal setup, we would say someone has a high IQ or emotional Q, or we would say that he or she is good in empathy, a very empathetic person. If that person can understand our mental state, right? If that person doesn't have a mental state, though person is great, we might not classify the other person as a great empathetic person. But if the other person knows our mental state and then respond to in a way that it acknowledges our mental state, then we say that, yeah, he is very empathetic. He or she is very empathetic, right? And in the same way, in the next level, if the person understand the other person's mental states, not only acknowledge and also proactively, not after something happens, proactively addresses that, you can call it as a next level empathy. So why don't we bring in the same concept here in the agents? So agents can understand the other person in a simple way, I know their beliefs, their other agents' belief, but I have a static response. It doesn't matter to me much. Though I know other agents' beliefs, here is my response, right? That's one way to respond. The second way is to know about other people's, sort of the BDI, belief, desire, intention. I keep track of that, right? And then I pick up, what is best for them and then respond back. You can call it as a second level empathy response. Third level, that is still a static. Third level could be very dynamic. As the conversation goes, for example, allies would understand, whatever response I'm making is that other agent is actually feeling good about that, right? Whatever I'm predicting, what he's going to say is actually what he is saying that. So in that sense, the allies will adjust its belief about the other person, and then keep tracks of the beliefs and desires and the intention of the other person. And based on that, allies will decide how to respond. So that's a level 3, if you say level 1, level 2, level 3 response, that's a level 3 kind of a response. So the idea is, it's a good idea. I never thought about this level in the agentic response implementation, but understanding we can actually go to that level 2, level 3, and respond back will improve our responses in a tremendous way. Okay, how do we do that? So that's what the paper is talking, right? So let's go to the paper. So in this paper, if you look at as you read later on in your time, you would quickly see that it directly goes to this picture. In this picture, you can see a few things. Bob is communicating, Alice is responding, but there is a conversational history is there. If you look at the conversation, so let's start with the belief. You can read through that. Bob believes his uncle's laziness is kind of a sin, and then Bob wants to have some change, decide to change his uncle, right? To change uncle's behavior. And the intention, Bob wants to express some dissatisfaction to the uncle. So this is current belief of the Bob. As he starts communicating, now the agents are communicating, right? Agents in the blue, Bob is in the blue color. He says, my uncle never does any homework, but sits playing all the time. And then Alice, which is going to be supposed to be the empathetic agent. Imagine Bob is the agent who needs sympathy needing agent, and Alice is the empathetic agent. And there are multiple methods this paper is explaining. As I was saying, level 1, level 2, level 3. I was positioning as level 1 response, level 2 response, level 3 response. Here, Alice keeps the beliefs of the Bob, all right? And then keep adjusting Bob's desires and beliefs and actions, intentions. How is she doing? This agent is doing by what they call counterfactual reflection. So remember in the level 3 category I mentioned, which is nothing but the counterfactual reflection. Basically, the allies would be able to keep track what Bob wants, and then based on the observed response and then predicted response, allies keeps a gap, reads in the gap, and then this agent would able to understand the what are the top K beliefs of the agent currently, and then reprioritize this what we call the beliefs BDI, the inferred BDI. The inferred BDI is the one keep updating by allies as the conversation proceeds. Now, the main message from this particular diagram is to say that without the TOM, the allies would simply respond, your uncle is pretty, is everything well? But with the TOM, she is able to acknowledge the allies. As a lazy person, he may deserve. I hope he could have some change. So this is a simple example, but the message you need to take is, the inferred BDI is a mechanism in which the counterfactual reflection is happening, and then allies would able to dynamically adjust a response, with the high empathy to the Bob. So that's the whole idea about this paper. That's the essence of the paper. Let's go further detail as you go down. So, now you may be wondering, it's interesting, but how the Bob or how the allies are actually making this choice, right? How they are actually defining the BDI, how they are actually updating the BDI. That's a paper in the next few slides. So what they are doing, in this paper, they are using LLM as the mechanism, right, as a reasoning engine, and to understand the BDI, infer the BDI, everything, all, inferring the BDI, understanding the gap, counterfactual reflection, everything happens through the LLM. Yes, they do. If you notice that in the bracket, they called LLMs. So that means in this paper, the authors used the LLM to infer the BDIs, and as well as in the Bob side, they use the LLMs to figure out the BDI of its own. And even the counterfactual reflection is happening through the LLMs. So everything is happening through the LLM. So it all comes to now prompt engineering. So at the end of the day, as the paper explains further, by having the good prompt engineering, we would be able to figure out a lot of these things. Let's see what the paper says. Okay. Let me go down. Yeah. Okay. So I'm going to directly go to the slide. Okay, there is a problem statement. Now that the paper explained, gave the introduction and sort of provided the high-level solution, they actually setting the problem statement clearly at this point. So at this point, now it makes sense to us. Given that BDAs are inherently latent, and discernible only from the ongoing dialogue, our core challenge is to simulate how agents might progressively recognize each other's genuine BDIs throughout their conversation and eventually benefit conversational communication. So that is a core problem statement, right? So why are they saying, why is that BDIs are unobservable, right? If you look at the diagram, I think if you go back to the diagram, for the allies doesn't know anything about the actual beliefs of the Bob. As the paper explains, it could be the agent, in the real setup, you can imagine that this may be the agent in some other part of the different, environment or system. There is no way that allies would know all the beliefs about this. There is no protocol that an ally is talking to Bob, hey, tell me what is your belief, desire, intention. There is no such protocol here. So allies need to figure out the Bob's belief, desire, intention through the conversation, right? Through the conversation, through the response, over the time, allies would be able to figure out. So that's a key aspect of the system. And it might start with a random. It's like in our part of our ML courses and all, right? The weights in the ML or starts with the random, and then as we train, it gets adjusted. In the same manner, the infer BDA might start with some random sort of beliefs and desire and intention about the Bob, and then it fines tune itself as the time goes based on the conversation. I think they mentioned that whatever I said somewhere in the paper, you can figure out that. All right, so as we go further down, I'm checking the time. We are in the middle right now. Okay. So there are three, having explained the problem statement, they are experimenting, right? Three different approaches. One, they are calling, basically, it comes to, if you go back to my level 1, level 2, level 3 sort of example, they are basically saying level 1, level 2, level 3. What is it here? What if they are talking two different scenarios. So since in this paper they cannot explain or communicate all the scenarios, they are saying that let's take an experiment where there is a self BDI. Imagine agent, right? One agent, let's call Bob is a self BDI, and then let's say allies is considered as a BDI tracking with CR means counter reflection. And then imagine some other agent, they don't have a CR, but they have something called vanilla BDI tracking. So in this one diagram, the authors are trying to explain, let's handle all the sort of scenarios. The middle one knows about himself or herself, that's self BDI, and the right hand one is the level 3 sort of enabled TOM, and then in the left hand side you can call it as a level 2 type of a response agent. So let's watch out here. I'll walk through the diagram, but then more explanations are here. You can read in your time. So for example, the way you can read this diagram is that from the conversational input, right, that's coming from chatbot or assistants. Imagine the self BDI is Bob, right? The Bob initially loads all the BDIs. You see that BDI initialization LLM. So just to help you out, what that could be, though paper explains in the next, just for reference purpose, to make it simple, I kind of put it in the side by side so that you can correlate little easily. So what that means is, the first step for the self BDI, let's say the Bob, is to initialize itself, right, with all the beliefs, desires, intention the Bob has. What that means, in terms of a little bit practical implementation, this is from the paper. They attached this as a reference in the bottom of the paper. So I'm bringing that up here so that you can correlate here. So what that means here is you may have, when you implement this, you might have such prompt. In this prompt, you construct this prompt, and then you initially it may be the empty dialogue, or it may be the previous dialogue happened over the history, and then you put all your definition of belief, desires, intention here, and then you ask the LLM to actually create a proper belief, desire, intention in an order or sequence of order or in some data structure, right? So this is how this part of this picture you can initialize your own belief, desire, and intention. So once you do that, right, learn BDIs through LLM, and then actually then it gets a BDI set, right? That's what it means. All right, once you're done, and then the next is, something you need to utter here, converse here, right? Let's say that you need to communicate to agent in the left. Then it could be a hello or how are you, something, you want to initiate some conversation, right? And then you might, if you go back to my example, it might be that this agent is wanting to communicate and get some information, whatever that is. Now you wanted to generate some something to the other agent. Now look at the corresponding prompt here, right? So prompt for utterance generation, right? So you may want to read more this on your time, but this is a prompt. This agent, the utterance generation component of this self BDI would be using, according to this paper, to generate a conversation, to start the conversation. So you can read this, basically, essentially it's giving some prompt, it's giving the conversation history, and then it's choosing one of the belief, desire, intention. Remember that it's already initialized with multiple beliefs and multiple desires. So somehow your agentic system chooses that one desire, one belief, one desire, and one path. And people who are familiar with the coding, right? The agentic coding, this red color means the parameters coming into the prompt, and it gets filled up by the higher level layer, which is our agentic implementation layer. So once this is filled up, and then once the prompt is sent to LLM, it generates a proper response, not proper, good response with as much empathy as it could at this point. And then you also give some end criteria for that communication. So but the point is the utterance generation LLM generates that, and then it sends to it sends to the other agent. Let's talk about, in this example, let's talk about it talks to the agent with the vanilla BDI tracking. It means the other agent has a L2 level thinking, response handling. So now the conversation comes to this other agent, and then this since it's a L2 type of a response agent in terms of empathy, it has a top, it keeps a top BDI. So this agent now knows what are the top BDI. Initially, it may be empty, but over the time, over the time, it will understand the Bob's intention, and then it will maintain the top one BDI, which is still the static, and then it generates a response, and then response sent to the Bob here, right? So that's the example of the self BDI tracking. So here you would see that there is no counterfactual reflection is happening. So that's actually happening in the right hand side, which is a L3 level type response. So let me pause here. I want to ask any questions now. Very few, maybe quickly. Then we'll move on to the next one. Any questions so far? Okay, thank you. So where are we now? So we now covered that right? Bob is able to talk to the vanilla BDI, then vanilla BDI able to respond back. Nice. Now extend the same concept to the right-hand side. And the right-hand side is a little bit advanced agent, you can call L3 type response agent. It's maintaining the counterfactual reflection, right? It's a little bit a combination of what is a counterfactual is about a couple of things. One, it's able to reflect and counter reflect. There are two concepts there. One, when I say understand the response coming from the, for example, this is Alice, this is Bob, understanding what Bob is saying, understand what I predicted. Over the time, it knows how to adjust the prediction gap and then adjust its top KBDIs. That's a one of that. If we can understand that from this paper, that gives us a lot of insight into how to do our agentic implementation. The paper explains it pretty well. They have the example. Let me take you through the example and then come back. Again, for your benefit, I put it in the right hand side here. Let me go back. Again, this is at the end of the paper, but this might be, you might be resonating. Okay, I'm sorry. I need to bake. Okay, 1 second. 1 second. Prompt of reflection. There should be counter reflection, should be there. Okay, this is the one. Okay. So what we are saying is this is a most I would say a little bit involved one, but that is the main aim of the agent, be at the L3 type response. Just let's follow this. Here what we are trying to do, the authors are trying to do here, a prompt for counterfactual reflection of inferred BDIs, right? Essentially, you have the conversational history. Conversational history is maintained by each agent. And then it also has a reflection history. Reflection history maintains in the past conversation, what was the scenario, right? What I predicted versus what really happened. Things like that is maintained in the reflection history. And then here the picture type here means, either it's one of the, belief, desire, or intention, right? And then inferred pic type, this is what today's current response, and then this is an inferred picked type, and then your prediction of latest response, the actual response coming from now, and then real response that happened. So all of them you put together in this prompt, and then you send it to LLM. So now see, the authors are using LLM to decide the confidence level of the belief and desire and intention I have, this agent, in this case Alice, has about Bob. So it's essentially using LLM as a mechanism to give back with a good confidence score. This is what I predicted, this is what it happened, and please tell me the confidence score, right? The LLM would be able to manage that and give the confidence score back to the agent. And then agent updates based on the response coming from that. Allies would be able to update is what they call top KBDI sets. Okay. So that's the idea, and that is a crucial idea here. And though this paper is not talking about the prompt at this point, it is much at the end, but you can parallelly see this is a prompt, it is doing it. So that's the three main concept. So if you go further, now a little bit with that concept, you can understand the sort of the little bit mathematics. I don't think even it's a mathematical formula like other papers. It's basically saying that the function of the response LLM, for example, the function in the response of this particular prompt is a function of conversational history, reflection history, and then picture type, and then the real response, and then actual, the predicted response. So that's the level of mathematics here. So there is no real challenge in the mathematics. It just dependent information needed to predict that particular aspect of the utterance. U means utterance of that particular time in the time sequence. Now, the way they explain this paper, I try to communicate by talking here, but you can read more about self BDI module. It's essentially about a function of the next utterance is a function of the prompt that we are sending, and then history it maintains, and then the BDI set it has, right? You can easily correlate when you go back to the first yeah, so you can easily correlate this equation, pretty simple, right? Okay. So whatever you see, the not initialization, the next one. Yeah. So the next utterance, that means response from the prompt, is a function of BDI and then conversational history, right? That's what it is about, BDI and conversational history. All right, and then P means the prompt you are constructing. So that's a level of equation here, and it's the same level followed in other parts of the document. And then zero shot BDI installation, we talked about that, right? To increase the randomness, okay, the initial BDI of agent A are learned from a randomly selected single episode of, this is what I was mentioning. The way you initialize the BDI, just get the existing, information. It may be available in the form of some rules or some document, and then initialize the BDI in the agent space. And then there is a concept called reverse BDI augmentation. And this is very interesting. If you look at, beliefs often reflects a personal subjectivity and may not always be correct, even morally wrong. So what they're saying, I think some of us who are doing a lot of the prompt engineering, we do that. When we look for an answer from LLM, if you're not convinced about that, we reverse the question and ask the LLM to know the answer. And then based on that, we judge the confidence, right? In the same sense, you can also incorporate the reverse BDI argumentation as in this process. Second order judgment, right? In order to implement the second order TOM judgment, I think the way the authors are implemented, at each round of the conversation, both parties have finished, the agent A then ponders means I believe, I don't know exactly what the author mean. It's probably trying to figure out, hey, are you happy? How are you doing now? Am I, answered you properly? Things like that, I think, is what it means. And then through which they are able to figure out the second order judgment's correctness, right? That's what this paper is trying to say. So what we are doing right now, what we are talking is of a self BDI, right? In my example, the Bob agent initialized, and it's able to use the reverse BDI sometimes, and it's able to use the second order judgment ideas presented in the paper sometimes. Now, same thing, if you can imagine the left-hand side from the diagram, that's a vanilla BDI tracking module. That is very simple, right? It does not do any counter reflection. It maintains the other side agents in some order, and then it responds back with the top one BDI. So it's kind of a little bit dumb. And then in my level 2, it is a level 2 type of response. Yeah, there is not much equation here. And then third one is the most interesting one. I think we are all wanting to, should be implementing the third one, which provides a high empathy, very dynamic in nature, right? Based on the conversation going on. So the paper explains a little bit detail about, how they are implemented, authors implemented the BDI tracking module. I'll let you read this, but essentially this is about two things. How do we find out the difference between predicted response and then actual response? How do we use LLM to rate these responses? How do we decide the new set of beliefs and desires and update my internal state, the mental state of the other side, mental state that is reflecting the other side agent, right? Those are the key concept. This is the most important concept from the paper. Please take your time and read. And concepts here used are reflection, foresight, and then counterfactual reflection. So in the reflection, the author says that, yes, we cannot reflect properly, because the BDE is unobservable, right? It results in the established reflection cannot directly evaluate the similarity between the inferred and the actual. So what they are proposing is, yes, reflection is important, but we will be using counterfactual reflection to to understand that. Counterfactual is nothing but comparing the predicted response and then actual response, and also is very interesting. Also, the thinking like this: what if I have a situation? Alice is probably thinking like this. I know the agent has, Bob has the situation, but let me think: what if I have a situation? And what would I be reacting myself, right? It is same as in human behavior, right? When we say we are highly empathetic, if you are able to understand others' feeling, others' state of mind, and asking ourselves, what the same thing happens to me, what would I be doing it, right? That's the same thing here. So if Alice is able to ask that question, Yes, I would able to, of course, understand the Bob's belief and desire by predicting and then comparing. But also let me ask, if the same situation happens to me, what should I be responding? What should be the response I will be actually liking it? So that kind of a question also, the allies can ask. And that is part of this thinking this agent can do it, right? So these are the three essential components of counterfactual reflection. You can read more on that, things like that. Then the authors going into the experimental setup. This is more of, I think we covered the theory and then concept at this point. Now let's look at the results from the paper. They took, essentially they took two paper sets. They explained that somewhere here. Let me see that. To make it easy, they have explained. Let me go to the little bit in the bottom. It's easy to visualize. Okay, data set, correct. So I think we start from the data set, the authors, right? And they essentially took something called empathetic dialogue and the persuasion dialogue. It has something like 25K conversation, and then persuasion dialogue has something like 1,000 something conversation. And this is a data set, just to let you know that this is how they actually trained the BDI based agent and also tested the BDI based agent. So with that, this is a starting point. And let me go quickly. We have 10-15 minutes more. And then with that, they started testing experiment. They did the experiment with that setup. And then they try to answer the following research question. To what extent could the TOM-aware agents infer about other generative agents, unobserved beliefs, desires, and intention? So that's the first question. The second question, they try to figure out what extent could the TOM-aware agents infer about counterpart agents' understanding of its own beliefs. That's called second order. And then I think the third one is what extent could the TOM-aware agents benefit downstream task of open domain conversation? See, open domain conversation, as you may know, it is like not a closed conversation. The conversation can go anywhere, any level, and there could be an end, may not be an end in the conversation. So there is so how does an agent conclude to stop it, right, at some point? And then how do they provide a very empathetic response? So that's all part of the open domain conversation interactions. So they try to test it with their idea, all these three categories of experiments. And then at the end of the day, the results are, the way they are concluding that is, if you look at here, they used different GPTs, and obviously, I don't, in this, they are not gone to other reasoning model, right? This might have a different or maybe better with the reasoning models, but these things, a little bit before our reasoning models. Still, the response, you could see that, the precision and then F1 score and recall substantially is, great in a GPT-4 compared to the other GPTs. So they are declaring that, the vanilla TOM plus CR is 0.47, and then they categorized into each one, for each belief, desire, and intentions. Because if you remember that, based on the response, they also might track, which response is actually making sense of that conversation, and for that response, they probably tracked the BDI behind the scene through some log or something, and then they categorize the answer accordingly. So this is they are reporting about the quality. Here quality means how good the truth is compared to the data set they have, in the base data set they have. And then similarly, there is another experiment they did is the second order TOM, right? They also see that in the second order TOM, if you look at here, the fact for the TOM, vanilla, when the belief, it's able to have a high number for the theory of mind plus CR, right? And then somehow for the desire and then intention, it's not, for the desire it's not much, for the intention it's matching very well. So anyway, these are all some of the results we need to peel the onion and then understand more. but that's authors have given that. All right, I'm just going down in the paper. So a lot of references here, and if you go down further, details of data sets are here, and then you may want to, if you want to learn more about how the prompts are being created, the one that I shared is partial prompt in the PowerPoint, but here they explained about all the prompts they use, like there are like 7 or 8 prompts out there, and one of the complicated one or important one I covered, which is the prompt for the CR, the level 3 type response. And then there are a few other prompts. You can take a look at that. All right, with that, I stop here. So I'm just concluding the paper, and why this is very important for us as sort of the GenAI developing community is to understand how we can take this and apply in our agentic framework implementation, correct? Framework or our agentic application implementation. So that's the next step we all need to do, right? And then potentially you may develop, for example, Crew AA may not be providing the construction to handle this BDI or keep a track of the inferred BDI. So this the current agentic platform may not provide that. You may need to think about extending your framework and then having these components as part of your current platform and then use it, right? That's interesting design thinking. We need to have it. How do we take this and apply to, for example, Crew AA implementation, right? Can we have a separate tool from Crew AA? These Crew AA constructs can utilize that and then derive the proper response. So these are all the things that anyway. So just to say that, right, in SupportVector, we are actually involved in the kind of extending the sort of taking these concepts and put that in practice, and by either way of utilizing some framework or enhancing the framework to achieve these things. All right, thank you. And if you don't have any questions, we can stop the recording.